Hello.
Yeah, hello, can you hear me?
Yeah, so now I can hear you. Yeah.
Okay.
Okay, so I hope now you're well. So basically today we will try to discuss about the rest of the part which is not completed, mainly water storage, volume of water area for the lake of Chad. Okay, this topic today we also try to cover, and we also try to calculate the area for water, how much area is available for that region. Okay, different time periods such as rainy season and wet season. Okay, so now we'll start our today's class. So
What of the graph? It's not running in my system. The link you sent to me, I couldn't get the graph.
yeah, okay, I also check the problem about that. What's the problem in here? I also try to check about that time series chart. Some data are missing. It's showing that some data set or some years values are missing for that region. So that's why this problem occurred. I also try to fix the problem and send you the link. No problem for that. So let's go over today's class. Can you see my screen?
Yes. No, not yet.
Yeah, so now can you see my screen? Yeah?
Yeah, it's coming. Yeah.
Okay, so let's go. Okay, so in previous class, we also try to discuss about that part, and we also try to calculate it, the normalized difference water index, and identify the water on the surface for as rainy season as well as also wet season. Okay, so you can see this is the NDBI for the rainy season, also NDBI for dry season. We can calculate it for the 2 time period. Okay, so now our main focus is that we need to calculate the volume of water or water body area. We need to calculate it. Okay, and also change the difference. What's the difference between the rainy season and wet season? How much area will be increasing or decreasing? So this type of analysis we can do in this time, and also try to show all of the things practically. So for that, here I already, okay, and previously we also tried to a lot of time for struggling to make the chart about that NDBI for dry season and NDBI for the rainy season. We face some problem in here because I make a mistake in here. This mistake is that when I want to make a function, you can see when I want to make a function, this element name image, okay, this same element I also need to use in here, then the chart will be appearing. Okay, but I use here the image collection filter rainy. I simply copy and paste here, but it will be image. Okay, which element name you put in here using the curly bracket. This is the argument. All of the argument will be happened according to your element name. Okay, so just I simply use the same name of element image in here also and create the band, and finally we can make the NDBI chart for the rainy season as well as also wet season. And when you want to check the result about the 2 time period, you can see this is the dry season as well as also we can get the rainy season. Okay, in this time we can easily identify the difference about from the chart. You can see this is the dry season, sorry, this is the rainy season and this is the dry season. Okay, so in this time we can get the for the dry season low NDBI value. Okay, negative, you can see most negative, but we can also get the some, you can see this graph is showing as this as the more or less. Okay, less value we can get in here, but also you can see for the rain season we can get the some values the up value. It also negative, but it also high level. Okay, high value we can get some in here, high value. Okay, and in this chart you can see this is the low, all of the value will be low. Okay, but when I can check that, you can see it will be some high value we can get find out in here, also some high value, also some high value we can get in here. Okay, so in this time high value for the NDBI, it's indicating the high pixel value of NDWI. High value means that of NDWI it showing the water pixel value. Okay, so in this time you can see we can get the rainy season NDWI and dry season NDWI. From the rainy season NDWI we just extract only for the water pixel value. Okay, so only for the extract for the water pixel value from this image. Okay, so it showing the NDWI, it showing the all of the things such as water body, vegetation, barrel, and all of the things it's showing. Okay, but in this time I want to just extract only for the water body pixel value. Okay, so water body pixel value, you can see this is the water body, we can easily find out that's water body pixel value. So all of this water body pixel value we just need to extract only for the water body for the rainy season and also for the dry season image, only for the water body pixel value. Okay, so let's go how we can easily do that. We also try to discuss about that, how we can easily extract the water body pixel value from these images. Okay, so in this time we need to use here the marks. Okay, so in this time you can see I simply take a variable, suppose I put a variable name, suppose water, suppose rainy. First of all I try to calculate the rainy season water volume or water area for rainy season. So take a variable water rainy, and now this is the image, you can see this is the image. Okay, this is the rainy season NDWI. Okay, NDWI for the rainy season. From this image I want to extract only for the water body pixel value. Okay, so I simply call this image variable name. This image variable name is that you can see this image variable name is the NDWI rainy. Okay, simply copy, because this image is the NDWI rainy season image in this stored in this image in variable. So I simply copy this variable and paste here. Okay, so now I want to select all of those pixel value which are greater than 0. So greater than 0, all of the pixel value indicating the water pixel value. So I put here the greater than 0. So it means that all of the pixel value which are greater than 0, we identify this is the water body and store it in this variable. Okay, so now let's display the result. So just put here this function such as put at the map dot add layer and then call the water rainy, simply copy and paste here. Okay, I want to display the result such as I make a color plated, so put here this plated and make the list of suppose I want to show, suppose put here the white color, there is the no water, and blue color there is the water, and so put the layer name, suppose this is the water rainy, click to run. So now it also added a new layer, you can see. From this layer we can get only for the water pixel value, we can easily find out the water pixel value, where the water is available or not, we can easily find out from this image. In this time all of the pixel value which are greater than 0, it identifies the water body for the NDWI, you can see. Okay, so white color is identify there is the no water, and blue color is identify there is the water. We can see we can get the another layer map in here. So now we can get all of those water body for the rainy season. So you can see this is the water body for the rainy season. Okay, and white color identify there is the no water body. Okay, this is the water body you can get in here. You can see this is the river, I think. Okay, also you can see water body, this is the water body, also some water body can get in here. So this is the water body, we can extract only for the water body pixel value from here for the region, and this time is the rainy season. You can see this is the water body, only water body, only water body, only water body can get in here. only water body. Yeah, this is the only water body you can get in here. You can see this river we can get in here. Okay, so you can get the only for the water. Okay, in this time, this pixel value for the blue color pixel value identify the greater than zero. Greater than zero, all of those pixel value we can identify as the water. Okay, and it's showing the water body. Now we can see we can easily identify the water from the NDBI. Okay, so in this time, after that, when we can get that, we also need to update. Okay, so we need to update marks function and update this water marks. Okay, so for that I can simply take a variable, suppose rainy water marks. Okay, after that I can simply call this water rainy and paste here and use a function, this function called the update marks, and update marks according to this ratio or threshold. This called the threshold. Okay, threshold means that when you want to extract any specific range of pixel value, then we are also applying the threshold. In this time my threshold is that all of those pixel value which are greater than 0 we can identify this is the water. Okay, so now I update this marks and want to show this result, such as map.add layer and call the rainy water marks. Simply copy and paste, and also add here this plated. Suppose I simply put this plated, put such as blue color, and then player name, suppose this is the rainy water. Okay, then click to the run. In this time we can actually also identify easily. Okay, you can see. In this time you can see when I this layer only showing the water pixel value, and see only for the water pixel value it's showing. Okay, so white pixel value will be removed. In this time you can see second layer is also available for the white pixel value. Okay, white pixel value, but and when I want to use here the update marks, now I get only for the pixel value of water body. So you can see this is the pixel value of water body you can get in here. Okay, so now I just calculated the result, how much water body area total, how much water volume is available for this rainy season. Okay, so this volume I want to calculate it from here. Easily we can calculate it. So for that we can use a function. So I simply take a variable, suppose this variable name is that rainy water area. Okay, so then I simply use a function, this function called that image dot pixel area, and use that the multiply function, multiply with this, simply copy this water pixel of this water and paste here. Okay, now I want to calculate the area. Just put here this, take a variable, suppose water area rainy. Okay, then call this variable name rainy water area and paste here, and use the function, this function called that reduce region. Okay, and put all of the things step by step. Just I simply make a dictionary, curly bracket start, and also curly bracket in. First of all, reducer, I just simply put here this dot reducer dot sum. In this time need to calculate the total pixel value of water. Then geometry, this is the boundary variable name is that region, put at the region. Scale is that for the lens set 30 meter resolution. CR is not need, I simply remove it. It's not need, best not need, I need the max pixel. So max pixel is that our big region, you can use it at the 1E 13. And tile scale not need, I simply remove it. After that, simply print rainy, print this variable name. So I simply call this variable name water rainy and paste here and click the run. So now it display the calculated the area, how much area is available for the water body in rainy season. We can get the value. Okay, we can get the value, you can see. And we can get the value in this time, you can see this unit is that a square kilometer. Sorry, a square meter. Okay, this unit is the square meter. Mainly when we want to perform the analysis using this function, we can get the result in square meter. So now I want to convert the square kilometer. Okay, so for that I simply take a variable. Suppose water area rainy, suppose a square kilometer. You can use any variable name, no problem. And call the e dot number function. Number, and call this variable name and put here the get function, get area, and it also divide 1E6. Okay, so now it convert as a square kilometer. So just print this value now, print this water area in rainy square kilometer, simply copy and paste and click the run. Okay, we can get it wrong in here. Okay, so area. Okay. Okay, so now we can get the result. You can see this is the 3,979 point something square kilometer for the water body in the rainy season. Okay, if you want, you can also use the round function. So simply use the round. Okay, so now we can get only for the integer value.
What does the round function do?
Round is only, you can see in this time there is the no faulting number. Okay, we can get only for the integer value. Okay, 3,979 square kilometer of the water body in the rainy season for the lake. So now, okay, just a minute. It's not it, I simply remove. I also put the citation such as this is the, I make a notation, citation such as this is the water body area in rainy season at Chad Lake. You can use any citation look like this, there is no problem. In this time we can see it will be showing the water body area in rainy season in Chad Lake. This is the, I also put the unit in here. There you can also put the another citation such as put here this unit is that square kilometer. Okay, then it also better. Okay, so now we can calculate the water body area in rainy season at the Lake of Chad, total 3,979 square kilometer. Okay, so now we also try to find out the dry season, what happened in the dry season for the how much area is available for the water body. We can also calculate it. Same process. Okay, just I simply copy the same code which I write already and then apply this code for the dry season. So okay, Okay, from here I simply copy. Simply copy the same code and apply again in here. Make the notation of this is the dry calculation. Okay. And write the code in here. Simply paste in here. Okay. Just I simply change the variable name. All of the things will be same. Suppose the water rainy, I simply put this. Suppose this is the water dry, and call this dry NDWI. You can see we already make the dry NDWI. So this is our dry NDWI, dry season NDWI. You can see, yeah, dry season NDWI. You can already calculated dry season NDWI. Okay. So I simply call this variable name of this image. What is the variable name? We can easily find out in here. You can see. Yeah, so this time period, okay. NDWI. Okay, so the NDWI, you can only use the NDWI for that dry season. Simply copy this variable name and paste here. And paste here. And from that, we can consider all of those pixel value which are greater than 0 as the water. We can consider it. So simply copy and paste here. And also this is the water for, I put the rename, suppose water for the dry season or dry. Okay, now we can check all of the things step by step. So I simply commenting all of those things in here and run the code. First of all, I run the code. So now we can see it also added another layer in here. It's showing the water for the dry season. In this time we can get the water body in the dry season of the lake of Chad.
I think, why did you use greater than 0?
Okay, so basically from that for the NDWI index, it ranges for the -1 to +1. So for the NDWI, all of those positive value, all of those positive pixel value is considered as a water body.
Okay.
Okay, all of those positive value in for the NDWI index.
Okay.
So now we can get the water body for the dry season. Okay, so you can see this is the water body for dry, and this is the water body for rainy. Okay, so now we can also try to add here this update max function. So for that, I simply take a variable. So I put the variable name, suppose in this time dry water max, and also call this variable name water dry and paste here, and also paste here. Now show the result. So just simply call the dry water max, simply copy and paste, and also put this is the dry season in it. Click on the run. Okay, so now I can get only for the dry water. Okay, dry water we can get in here, and also we can get the rainy water. You can see this is the rainy water and this is the dry water. Okay, so you can see now we can calculate the how much dry water we can calculate it this time. Yeah, so for that same process, you can simply use this code rainy water area. In this time, I simply put this. Suppose this is the
Dry water.
dry water, dry water area, and then copy this variable name and paste here, and also uncomment this. Water. I put this suppose dry. Dry. Then simply copy this variable name and paste here. After that, use the reduced region. All of this will be same. And also show the result. Put at the water. I put at the suppose this is the dry. And put call this variable name dry area. Paste here. Okay. And after that, we can print that result. Simply water body in the suppose dry season. And copy this water area in the dry square kilometer and paste here. All of the things and click to the run. So now we can get also the water body area in the dry season. Okay, so now it's computing this value. Okay, so it's working. And we can also get all of this dry season water, how much water body, rainy season. Okay, all of the map we can also create it in here. If you want, you can easily export all of the map for the dry season water, then also rainy season water. We can easily export from here and also make the final map in our ArcMap software. You can see all of the water body can easily extract from here. You can see this is the river, okay, and also you can see this is the lake, okay, and different time period, dry season and water and rainy season. We can easily get all of the things in here.
So what we just calculated is the area.
Yeah, area. How much water body is available for the dry season as well as also rainy season.
Okay. What of, I think it should be the same thing with the volume, right?
Yeah.
Is it the same thing with the volume of water?
Yeah, so it's the volume of water. Yeah. Water body area. Volume of water body area.
Okay. Volume.
It takes some time.
Yeah.
So I run again. I think some networking issue. But that Okay, so now I can get the result. You can see we can get the result in here. Water body area in dry season, we can get the 6,705 square kilometer, and rainy season we can get that area 3,979 square kilometer area. Okay, we can get the result look like this.
Why is the rainy season, the dry season, why is it that dry season has more water than rainy season?
Yeah, so I also thinking about that. What's the region for that? Why this is the showing the dry season time period that the lot of water region, but it's showing also rainy season but the some less. Okay, so do you have any idea about that?
I don't know. I don't know why the rainy season is the dry season is higher than the rainy season.
Yeah. So did you check the time period again? Again, check the time period. We can check the time period for our rainy season, dry season. Okay, so
I think it will be that in dry season, water comes from the rivers. Too much water comes from the rivers.
in dry season.
Yeah.
Yeah. So this is the another region, I think, also for that water body will be increasing in the dry season. Okay, so this is another reason I can say. But we can perform this time period and we can extract the data set from the satellite images. So that's why there is the no doubt about this value. Okay, so we if we face a problem in here the time period such as rainy season, dry season. Otherwise, it has also another region for the increasing the water body in the dry season than rainy season.
Okay.
Okay, so this is the process you can see. Okay, so you can check the time period is that dry season time period. You can put this time period. Okay, from January, February, March, April, May, June, July, August, September to March. Also for the rainy season, you can put this time period. Yeah, this is the January, February, March, April, May, May to October. This time period can put in here.
June, July, October. That's the dry season, right? Rainy season. May.
Yeah, this is rainy season. Yeah.
May, June, July, August, September, October.
Yeah. So put this rainy season. Okay, and also.
It's okay.
And also check the image. If you want to check the image, then we can also get the variation about that rainy season and dry season. Okay, so it's showing the dry in the water in the rainy season. So dry season water. This is the dry season water.
Yeah.
And this is the rainy season water.
Yes.
So we can easily find out the visualization. We can get the lot of water body will be increasing in the dry season period.
Yeah.
So you can see water will be increasing. A lot of place water body is increasing. Okay, if you want to check from here, suppose you can see this is the dry, and you can see this is the rainy season. In this time it's showing the rainy season. When I open the dry, taken care of, the lot of water will fill up.
Yeah.
So in the dry season, water volume is increased than rain season.
Yes.
Okay, so this is the process, and this is our first objective about that. How you can easily make the volume of water area in the lake chart for the different time period. Okay, so this is the first objective, and second objective is that you can also add here the some. Okay, I simply open your file. Right. Okay, then we also need to, okay, so water and we can just do that, change in the volume of area of the lake chart. Okay, then analyze the factors for the such as LST, evapotranspiration, surface evaporation, irrigation, albedo, okay, heat island, NDBI, NDBI, lot of indices during the rainy season and also wet season. Okay, so analyze the factors. So in this time we also try to discuss about that for the NDBI and NDWI. Okay, I think it already done about that part. Okay, so I simply open our code in here. So in the same code we also try to calculate some indices such as NDBI, SAVI, EVI. Okay, all things we already perform in here. And we also need to make the time series chart about that. So we can see this is the EVI. We already calculated the EVI. Okay, and what is the time period of the EVI? You can put in here. We can check the EVI time period. So EVI filtered, we can use at the filtered image. So filtered image time period is that. Okay, 2020. Okay, so 2020 is the done for calculating the EVI, SAVI, NDVI, as well as also NDWI. So this is the NDWI. Okay, and in this time you want to mention the time chart. Oh my god, during the rainy season as well as also need the for the dry season. So for the rainy season, for the 1990 rainy season and 1990 also for the dry season, 2020 also rainy season and 2020 also dry season.
No,
Okay,
it's 10 years interval, like 1990, okay,
yeah,
2000, 2010,
10.
2020. That should be 4 images divided by
Okay,
4. That's 8. Yeah.
okay. So in this time, in
I
this
have a
this
question.
code,
I have a question.
yeah, please,
Can you open the objective, please?
yeah.
The change in volume and area. I think these are 2 different things. Or maybe I should read about it and get back to you.
Yeah.
I think we just got the change in area, not the volume actually. The volume should be in a cubic meter.
Yeah, so you also need to perform the change area. Okay, so in this time, we can just calculate it the only for the year of 2020.
Yes.
Okay, so this time period we can calculate. In this time, this showing only for the NWI and dry season 2020. Okay, and in this time you also perform the same analysis for 1990. Okay, so I also send you this code link, so you also try to do for your own self for calculating this same analysis. All of those things same, such as you want to calculate the NDVI, NDWI, EVI, all of those things you can perform the year of 1990, then 2000, 2010 and 2020 is already done in here for this all of the things. Okay, so in this time you also try to do for that same process. You can take the satellite images and filter all of the things and then take this make this analysis, the same process. In this time here we can calculate it all of those things for year of 2020. Okay, so all of the things we can calculate it for the 2020, but we also need the for other 3 years, such as 1990, 2000, and 2010. Okay, so 3 hours satellite image you also need for this region. Okay, so you also take this satellite images 3 years, and then also make the same process for analysis, and also make this perform the analysis. So in this time I also complete, first of all I completed the only for the year of 2020, all of those things we completed. Okay, then we can simply make the other 3 years map. When it will be completed, then also move to the change detection between the year of 1990 to 2010. So this type of change detection we can perform. Okay, so in this time I can check, in this time we also need to calculate it in here. What is the we need calculated? So we can calculate it the, okay, NDBI is done, NDWI is done, NDBI you also need to perform the NDBI. Okay, so in this time also I had the NDBI for this region. Okay, so in this time there is no NDBI, so for this I also perform the NDBI in here. Okay, so let's go for NDBI for the dry season and the rainy season. We can calculate it that. And I think we are also calculating the NDVI or EVI only for the year of 2020, not any specific time period. Okay, so in this time we also perform the time period such as, okay, so let's go. So first of all we consider as a filtered, suppose I filtered this for a dry season. Okay, and put this dry season time period from, what is the time period? 09 from 05. Yeah. Okay, and I simply copy this variable name and perform the all of the analysis for the dry season. So simply copy, also show the image and paste here. Okay, and put the, suppose this is the NDVI dry, and simply copy that and paste here. Okay, so now NDBI dry is open. I also put this, suppose this is the NDBI dry, and after that Savi, so I simply call this filter dry image. I simply copy this variable name and paste here. Okay, expression same, all of them will be same. I put this Savi for dry. Okay, and also show the result for Savi. I simply put here this Savi dry. Okay, it's also I put the layer name, suppose Savi dry. And then also for EVI, so I put at this filtered dry. I call the dry image. Okay, and also call this filter dry. Okay, and also need to put here, suppose this is the filter dry. Filter dry is mainly stored the satellite image. Okay, and all the same. Okay, and EVI for dry, simply copy and paste here. Okay, so it's done for the dry season. Is that done? In this time I also put the same for the rainy season. Okay, so for the rainy season I simply put at the rainy season indices and call the same code. I simply copy the same code from here. So just simply copy, just I change the variable name and also change the time period. Okay, then it will be easily, we can easily calculate it, all of the things from here. Simply copy and paste. Okay, so now I can simply put here this, suppose filtered NDWI for, I simply put the, suppose the wet season or wet or rainy. I put here the rainy. Okay, and put here this, first of all put here this time period, such as what is the time period for the rainy season 2020?
May to November.
Okay. Okay, so
October.
October from
May to October.
05 to October.
Can we check that the other one so that let's be sure?
Yeah. Okay, then simply copy and paste. Okay, field rainy is available. Okay, and also put this as NDBI rainy. Okay, simply copy this variable name. Copy this variable name and paste here. And also put the layer name such as NDBI rainy. And then also call this filter rainy. Okay, what's not increasing the suppose 50%. Yeah, that is not effect for the cloud. Okay, rainy. Filter rainy. Put at the survey for rainy. Okay, and also put at the survey for rainy. Okay, and also put the layer name survey rainy. So filter rain for the satellite image. And I'll put this EVI for rainy. Okay, and then simply copy, also change the name such as EVI rainy. Okay, after that I simply change the layer name in here such as, put the EVI rainy. Then it's AVI or right. Now let's check. So now we can get all of those for the 2 time period, rainy season and dry season. Okay, and we also need to calculate for the other indices such as NDBI or other things for the rainy and offset. So I will perform all of the analysis for the year of 2020. Okay, so then when you want to perform the for the other time period, just you have to call the satellite image for the other time period and also apply the same process. Just simply copy and paste this code. I hope you can easily do that. There is no much hard.
Okay. I want to ask is just, I have a question, but it's outside this place. Like how when I open the data set of GEE,
Yeah.
like images have, how do I know the particular one and which
Okay, so I did not hear you properly.
I'm coming. How do I know that this answer 7, this is the year it covered?
Your voice is not clear. Your voice is not clear. I did not hear you properly.
Saying if I go to the data set,
Yeah.
how do I know that this particular set, this is the year it is covering, and I can get that for this year?
Okay, so it's depend on your time duration. Okay, suppose you can see when I want to go to this satellite image, browse data catalog, here I can get all of those satellite images for the Landsat. So I simply click on the Landsat. Suppose I need the image for 2010. Okay, so you can check the time period which are available for the 2010. You can see you can use here the Landsat 7 ETM plus. It also available the time period for 2010 and also available for the Landsat 5. It also available for the for this 2010. Okay, so in this time if you want you can use here the Landsat 7 ETM plus. Okay, and get the image for the 2010. Okay, suppose you want to work for the 2000, then you can check here. It also available for the Landsat 7 also, and also available for the Landsat 5. Okay, then you can use that the anyone. Actually, you find out which image is better for your region. Sometime you can get the suppose Lancet 7 is better for your region. Sometime you find out the Lancet 5 is the better for your region. Okay, so which image is clear, which image is the totally cloud free, totally noise free, then you can use this image and perform the analysis.
So how do I know the ones that are noise free are compatible for my area? How do I find it?
You have to check it. Okay, you have to check it. You just import the image and make the code. Okay, and display the image. You just display the image, then you face the problem. You can find out the some noisy line. You can find out the some cloud, some tiles are unmixing. So then you can also use here the another image and try to find out what is the situation about this image. Okay, and when you can get the fine image or good image, then you can use it.
Okay. That's right.
Okay, so in this way we can calculate all of the things. Okay, so now we need to perform the NDBI. Suppose I want to perform the NDBI. So okay, so for the rainy season and dry season. Okay, for that. Okay. So I perform the analysis of the NDBI. So take a variable, suppose NDBI, and call this filter dry. This is the image. I simply copy and paste here and use a function normalize difference. What is the formula of the NDBI? You can easily find out in simply search at the NDBI index formula, normalized difference built up index. And we can get the short wave infrared minus near infrared. So short wave infrared and near infrared band we need. So I simply open my code and try to find out the short wave infrared and near infrared. So I can simply open my image collection, simply copy and paste and check what is the band name. Short wave infrared and near infrared. So you can see near infrared is the B5 and short wave infrared is the B6. So B6 and B5. So B6 and B5. B6 and B5. I need to use at the B6. Okay, B6 and also put at the B5 near infrared and short wave infrared one, and also put this name, suppose rename function, and put this name such as NDBI. I know display the result. Just put here the map dot add layer and call the NDBI. Put at the visualizer such as mean -1, max +1. Put here this plated and make the list of plated. So I put here the blue, then white and red. Okay, and also put it mentioned that it is that NDBI for dry. Okay, now simply copy the same code. Okay, I put this as NDBI dry and also put this NDBI dry. Simply copy and paste here and call the rainy season image. Simply copy this variable name and paste here. Suppose NDBI for rainy. Simply copy this and also put here NDBI rainy And then all of the things, okay, I put at the NDBI, NDBI rainy. Click to the run. So now we can get the rainy season NDBI for the 2 time period. So we can get here, you can see NDBI rainy and so these are rainy and this is dry. This is a dry NDBI. I'm here and open this rainy NDBI, you can see. Okay, so we can check after that what you want to need. After that, EVI is done, NDWI done, NDVI done. And you also need to calculate the relative humidity. Okay, heat flux, relative humidity. Okay. Also LST, then evapotranspiration, surface evaporation, irrigation. So we try to perform the LST, okay, and for the different season. Okay, so for that, okay, so in this time I open a new code editor because in this time lot of layer will be added in here. So I open a new code editor and try to perform the LST, okay, separately. Then it's also better. So I open a new code editor. Okay, so I simply use this same code and then simply call your area. Your area is that. Simply copy this area. And it will be geometry. Okay, now check about that result.
I think one parameter is
Okay, it's showing the lot of pixel value because this is the big region. So this is the one of the problem. So in this time, we also mentioned here the max pixel value.
Okay, it's like you already have the code.
Yeah, I already read the code about that. Okay, so in this time it's showing that the max pixel allows only for this value, and this is a big region, so that's why it's showing the lot of pixel value. Okay, so in this time we will fix the problem and then try to solve the make the land surface temperature monitoring.